Yeah, the Port of Antwerp. We're centered in Europe. We're an inland port, which arrives a lot of big vessels. We're 80 kilometers inland on the River Schelde. So 80, yeah. This is our port for the moment. They're still thinking about expanding. We have one big dock that's obtained to the fluctuation of the river. The other docks are all behind the locks, so that's a little bit easier for us to survey. So we have a lot of projects in the Port of Antwerp about deepening our quay walls. We get a lot of bigger ships, a lot more draft of the ships. So we are an old port and we don't have much room to expand. So we're always trying to find new ways to let those bigger vessels come into port. Therefore we are taking new structures in front of the old structures, so we don't throw everything away. It's just renovation projects in which we're going to deepen the quay walls. Of course, this takes a lot of engineering, but also a lot of studying to deepen, and before dredging, we need to know where we can go with the material that's coming out. So the study in advance is quite big. So this is a project I took as a reference for today. It's the fourth port dock that we're talking about. We had a small bit of the dock already deepened. You can see the green area. So the other part was to build to the quay wall on the north side. The first thing, of course, is to do the survey. We, as the survey company of the Port of Antwerp, survey all the docks 2 times a year. And we can take that as a start survey to do all the dredge works that we're going to do. So, also on that start survey, we make the theoretical seafloor where we're going to go to and make all the calculations on the volumes. Depending on those volumes, we need to take samples for the environmental, but also we need to know where there's silt and where there's sand. So we're trying to split it up. You see in the next slides, it's important for the later on processing of the mud, especially when it's contaminated. So first of all, of course, we have objects. In this area we had some iron sheeting, some big slabs that were lost cargo. So we had to remove them. So first we detect them. These are all detected with the standard multi-beam system from Teledyne. And then we remove them with a big crane and divers who lock them underwater. So these are sheets about 4 meters to 10 meters. Also, with everything we find, we make a data sheet of it. So first we find an object, we make a data sheet of where it is, and when we salvage it, we put it in the sheet so everything gets documented very well, what was on the seafloor. We took a lot about on this location, a lot of sheet pilings, a lot of iron sheets, iron tubings, and still we didn't have everything because a couple of weeks ago in the project, during dredge works, they stumbled onto a bomb. So everything was in highly alarm phase. So the bomb was removed, it wasn't harmful. So the OVO we have in Belgium, it's the military who takes out bombs and deposits them, so they came and took it away. All the dredge works are back on time now, so. So in the first stage of the project, we need to determine the zone that we want to dredge. We made the volume calculations that I said earlier to make where we can take the environmental samples. Normally we take environmental samples with a Van Veengrap, and when it's getting to be deepened, we do use fibercores or central drillings. So we get a fine core base, what we're going to find on the seafloor. In the first step, in this zone, we started with the Van Veengraps to determine, especially for the environmental, what is all in the silty parts. So this is how we take our vibrocores and drillings. So we split them up in layers on the seafloor in specific areas, and then we go. The laboratory takes all the samples, analyzes them. We get sand results, grain sizes, and all the contaminations. So here we had a lot of contamination of mineral oil, TBGs from earlier paints they used on the vessels. Also PHAs and PCBs that we found. So it was a little bit difficult just to remove the mud and stock it somewhere. They don't like it that much. In the beginning they had this policy, when the silt stayed underwater, it didn't matter. So we did a lot of plow works, so we just moved the silt on the bottom, but now that we have to deepen it, and then again regulations changed, and they said, okay, when we move all the emulsion, the contamination gets into the water column, so we can't do that anymore also. So we also split it up between silt and sand. So why do we do this? Because everything we do in the Port of Antwerp, when it's silt, they see it as maintenance dredge work. And maintenance dredge work, we do it ourselves. When it's sand, it's a constructional dredge work, so we're deepening the seafloor, and then most of the time it's given out to other companies to do effectively the deepening out of the canals. So like I said, on the vibrocores, we take them, and the first idea you get of them, when you open them, you can see where there's a determination of sand and silt. So that's the first step that we take. We know how deep the core went, and then we can say, okay, from that point on, that's a sandy layer, and that's a silty layer. Later on, when the effectively measurements come from the laboratory, we know that probably some things that we thought were silt may contaminate a lot of fractures, more than 63 microns, and then it's sand. So to dredge the layer of silt above the sand, because probably you will think, okay, we take a point and it's one flat surface of sand. But in this area we had probably in the past some areas that they deepened a lot more, and they filled up again with silt. So we took the vibrocores and we made a point file where we could find the difference between silt and sand. We put it into a model. We put it in what I got Civil 3D to make the model, triangulated it, and then we made a 3D surface of it to put in the PDS computer for the crane. So on this model we took also the stop, so the crane couldn't dredge any deeper than the model was saying. So this was the difference model that we made to the sand and silt difference from our survey to the layer. So we got a volume of how much silt we were going to dredge. And then we did the same study to the sandy layer, to where we theoretically wanted to go to deepening the dock. So it's all in study in advance. Of course, yeah, theoretically everything is very beautiful. You see on the screen we had a lot of points that we vibro-carved. Vibro-carving isn't that cheap, so, but actually we could have used some more. Now we found that there were places when we set the crane and we put the piles of the crane down, the pile just went deeper down into the bottom. So it's a picture I don't have with me, but last time we did a survey, we used the backscatter information to see if there was any, what the sand to the silt said. We got a pretty good image of it and we checked it with the crane. So when it was saying it was sand, we took a grab and yeah, it was sand. And indeed, where the crane operator said his pole was going into the seafloor, there we saw a nice volume of still silt. So that was a nice picture. Badly, I didn't have a picture with me. So we dredged with our bow spring. It's a balance spring, and we used split barges to load. The split barges we can use in two ways. We can just load them and unload them by splitting them open. But when you're speaking about contaminated mud with the TBTs and the PCBs and PHPs and all that other stuff, they don't like it very much because it all gets into the water column. So you're going to take it to a clean environment and get lost of all the work you did to keep it contaminated. So.
What? Going to France?
They're going, no, they're not going to France with it. No. We have a facility now where we can process it. Before we didn't have, and we have to take it to Holland, to Rotterdam, to the Slufter. But they didn't like it very much because they don't like when you take contaminated mud and materials from one country to another country. It's a bit difficult. So now we have the mud. It's very important for the facility where we process it. So the facility for processing is called Amaras. It's in the Port of Antwerp, where you'll see the small electric cutter dredger. It can dredge up again from, we made a depth where they can split open the barges. So when it's clean mud, they just split open and they go back. It takes a lot less time, and they dredge it back up, put water in it to filter it. So it's pretty easy. But now with the contaminated mud, they have to pump it out of the barge. So that was, it's time consuming because it takes 4 to 6 hours to clean out the barge. And they don't like too much sand inside of it. So when it's more than 50% sand, they say no, we don't do this anymore. So that's a little bit of a problem. Because at first, when it's getting pumped out, it's getting pumped to the sand separation system. For the first part that it goes through in the sand separation, it goes to a sieve where all particles above 8 millimeters get filtered out. So small rocks, plastics, metals that are still inside it get filtered out. Then they go to the hydrocyclones and they filter out, they separate to the particles of 63 microns, and then the sand gets dumped into a sandstock. Of course, when it's contaminated sand, they clean it with water, and the idea is that the contamination isn't in the sand but in the water. This water gets pumped again with the silty parts, smaller than 63 microns, to the facility further on. So we're pumping it by 3 pipes. They're about half a meter of diameter. There are 2 pipes going to the facility with silt and water, and 1 pipe for the return water of clean water. And it goes back into the docks. So in the first stage, when it arrives at the factory, you have the sediment ponds. There are 4 ponds, and there's only 1 pond for contaminated mud. So all the rest has to be with clean mud and clean water. So the big bridge you see in the middle, there's also a dredge head on it, and they dredge it back out the mud. So the sediment falls down and then they dredge it back up. The overflow of water that comes out will later on go back to the canal after water cleaning. So when it arrives at the factory, the picture on the right-hand corner, you see those 2 big silos. They're stocked with chalk, and they make a chalk milk that they mix with the mud to dry it out. Then they put it into big pressure filters. They press out all the water. The water goes to the water purification center, and the dried out mud goes to the stock of the mud. So here we have the water purification center. They have several steps of purification. This is not my area of expertise, but first they start with normal purification of sinking the heavier parts, and then they go with chemical purification and stuff like that until it's clean enough to turn it back to the dock water. Of course, when we have the dried out, we call it dried biscuits of silt. They fall onto conveyor belts and they get exported to a land dump. To start up the land dump, first they have to have more than 6 meters of uncontaminated biscuits. Then they put on a layer of geotextile. Then again 6 meters of uncontaminated, and then they could start with contaminated mud. So the project that we started with was a project we started in 2013, but the facility wasn't capable of accepting contaminated mud at that moment. So we just started early this year to bring the contaminated mud to this facility. It is being brought there by conveyor belts, and further on it's being spread out just by heavy machinery. So this is a little bit the steps of how it works. So at point 1 is getting either dumped or pumped out, and again separate the sand. The transport to those pipes is something more than 3 kilometers. So we do have a lot of water pumped in with it to get it to the facility. Then it goes to the ponds where it settles in. That's at number 6 and 4. The water purification, and then the stockage at number 7. I put a YouTube link in, but maybe it's easy when you want to see a movie about the factory. It's a very nice movie, it takes about 9 minutes. Just put in Amaras and you'll find it on YouTube. So that's it. If you have any questions.